In today's lesson, we are going to talk about how to solve a system of linear quadratic equations. In grade 10, you learned how to solve a system of linear equations. An example of system of linear equations was something like y is equal to 3x plus 1 and y is equal to 2x minus 5. And the way that we solved it was with three techniques. One was substitution, elimination, or graphing. And the process was simple. We were looking at the problem. If the coefficient of x or y was 1 in both equations, we could use substitution, and if the coefficients were different in two equations, we were using elimination, and graphing was the last resort. If you had access to technology, you could plot the two lines and then you would detect the point of intersection. But in today's lesson, we are going to talk about how to solve a system where one equation is linear, the other one is quadratic. For example, you can have a parabola like the one which is shown and a line which crosses the parabola at 2 points. Now, as you can guess, there are three possibilities for this case between a line and a parabola. You can either have the case that the two will never intersect. For instance, for a case like this one, they never intersect. You can have another case that they intersect only at one point, like this one, which is, this is the line, this is the point that they intersect. Or you can have the case that they intercept at 2 points, like this one. Now, we have a special name for the line and the parabola when they intercept only at one point here. This line, in this case is called tangent line. So tangent line is when it touches the graph only at one point, and this is the point. We call this line secant. This is the line that crosses the graph at 2 points, like this. Now you will see how we can use this idea to solve some real-life application out there. In the first example, Sabrina has a banner which is at an angle across an archway. The arc is in the form of a parabola. So let's draw the case. This is the parabola, and let's assume this is the banner. Now the equation of the banner is y is equal to 0.24x plus 7.2, and the equation of the parabola or the arc is y is equal to negative 0.48x squared plus 4.8x. The question is, what is the coordinates of the points where the two functions intersect, meaning these 2 points? Since the line and the parabola, they intersect, we have to solve the system of linear quadratic equation given here. If you look at both equations, you can see both of them are equal to y. So this means that the right-hand side of the equations, meaning here and here, they also have to be equal. So we can say that 0.24 x plus 7.2 has to be equal to negative 0.48 x squared plus 4.8x. We are using the substitution technique. We're substituting y from one equation into another one. Now I'm going to bring everything to the right, and after simplification I'm going to get negative 0.48 x squared plus 4.8x minus 0.24x minus 7.2 is equal to 0. So I get negative 0.48x squared. Now if you simplify 4.8 minus 0.24, we are going to get 4.56x minus 7.2 is equal to 0. Now this is a quadratic function. I'm going to use quadratic formula. The discriminant is d is b squared minus 4ac, which is 4.56 squared minus 4 times negative 0.48 times negative 7.2. Now if you simplify this one, we will find that d is equal to 6.9696. So this is our discriminant. Since the discriminant is greater than 0, this means that there are two solutions, or two zeros. Now we have to use quadratic formula to find the x-coordinate of the points of intersection. Using quadratic formula, we can say that x1 and 2 is negative b, which is negative 4.56, plus or minus square root of 6.9696 divided by 2a, which is 2 times negative 0.48, which is going to be negative 4.56 plus or minus 2.64, because square root of 6.9696 is 2.64 divided by negative 0.96, because 2 times negative 0.48 is negative 0.96. If we take the positive here, the plus 1, we get 2 if you simplify it. If you get the negative 1, you get 7.5. So the point of intersections, there are two of them, and one of them has the x coordinate of 2, the other one 7.5. Now you can use any one of these two equations, either the line or quadratic, to find the y coordinate. I'm going to use the line. So if x is 2, then y is equal to 0.24 times 2 plus 7.2. If you simplify this one, you get 7.68. So the first point of intersection is 2 and 7.68. If x is equal to 7.5, then y is 0.24 times 7.5 plus 7.2. If you simplify this one, you get 9. So we say that the next point of intersection is 7.5 and 9. The next part of the problem asks to interpret the solution in the context. Again, we go back to our situation. We have an arc here. This is our banner. We know that the point of intersections here are given by 2 and 7.68, and the other one is 7.5 and 9. One way to interpret the solution is that when Sabrina wants to attach the banner to the arc, these 2 points are the places that she has to either nail the banner or use screws or whatever. So she knows that 2 meters to the right and 7.68 meters up is the first place, and the next one is 7.5 meters to the right and 9 meters up the arc, so she can just nail them to secure them over the arc. In the next example, we have been given two equations, one which is linear and the other one which is quadratic, and we are supposed to find the number of intersection points. To do that one, we are going to try to solve the two equations to find the point of intersections. So I'm going to use substitution since both of them y's, the coefficient is 1. So I'm going to make one equal to the other one. So I'm going to say 3x squared minus 2x minus 4 is equal to 3x plus 5. I'm going to move both to the left. I get 3x squared minus 2x minus 4 minus 3x minus 5 is equal to 0. But after simplification, I get 3x squared minus 5x minus 9 is equal to 0. The discriminant here is b squared, which is negative 5 squared minus 4ac, which is negative 4 times 3 times negative 9. If you simplify this one, then you are going to get 133, which is greater than 0, so this means that there are 2 points of intersection. Remember that this is your parabola, because leading coefficient is 3 is greater than 0, so it opens upward, and this is your line. There are 2 points of intersections, and this means that the line y equal to 3x plus 5 is a secant line, because there are 2 points of intersection here. In the next example, we have a line y equal negative x minus 2 and the quadratic y equal negative 2x squared plus x minus 3. We exactly do the same thing. We are going to solve these two using substitution. So I'm going to say negative 2x squared plus x minus 3 is equal to negative x minus 2. I'm going to bring these two to the left. I get negative 2x squared plus x minus 3, negative x becomes plus x, negative 2 becomes plus 2. Now this simplifies to negative 2x squared. X plus x gives me 2x. Negative 3 plus 2 gives me negative 1 equal to 0. Now if we find the discriminant, d is equal to b squared, which is 2 squared, minus 4. A is negative 2 times c, which is negative 1. This gives me 4. Negative times negative times negative gives me negative. 4 times 2 gives me 8. This is negative 4 less than 0, so this means no point of intersection. This means that I have a case of because leading coefficient is negative 2, the parabola opens downward. And then I'm going to have a case like a line like this one. So there is no point of intersection here between the line and the parabola. In the next example, we know that the line has slope 4. And also, we know that the line intersects a parabola y equal half x squared plus 2x minus 8 only at one point. So the line is really a tangent line to the parabola. What is the y-intercept of the line, and what is the slope y-intercept form of the equation of the line? So we know that the line has a slope of 4, so we can write that y is equal to 4x plus b. B is the y-intercept we have to find. Now, we want to find the point of intersection between this line and the quadratic, half x squared plus 2x minus 8. So we can use the substitution method as we discussed before and find the point of intersections. So I'm going to move these to the right. I get half x squared plus 2x minus 8 minus 4x minus b is equal to 0. Simplifying, we get half x squared. 2x minus 4x gives me minus 2x minus 8 minus b is equal to 0. Now we can find the discriminant. D is b squared minus 2 squared minus 4a times c. Now remember that the problem is telling us that there is only one point of intersection, so this means that the discriminant has to be 0. So we can solve this equation for b. Negative 2 squared is 4. Negative 4 times 1 over 2 is negative 2, so this one is negative 2. Now I'm going to erase this negative here so you won't get confused here. So negative 2 times negative 8 gives me plus 16. Negative 2 times negative b gives me plus 2b is equal to 0. 4 plus 16 gives me 20. If I move 20 to the right, I get 2b is negative 20, or b is negative 10. This means that our line becomes y is equal mx 4x minus 10. So this is the tangent line to this parabola, and the question doesn't ask us to find point of intersection, but you can easily, do the same thing and try to find what is the point of intersection between this line and the parabola. In the next example, we have Dudley Do-Right, which is riding his horse. His speed is 10 meters per second, and he's riding the horse toward the bank. Initially, he is 100 meters away, and at the same time, a bank robber begins to accelerate away from the bank at the same direction as Dudley Do-Right, and his distance, the bank robber, as a function of time is given by this equation. D is equal to 0.t squared, 0.2t squared. Now the first part of the question is write an equation modeling the position of Dudley Do-Right as a function of time. Let's assume that the bank is at the origin. Initially, Dudley Do-Right is 100 meters away from the bank. So if this is the origin, where is the bank? Dudley Do-Right is here, which is 100 meters away. So I can write the distance is, first of all, it's 100 meters away, so it's negative 100, and it's going 10 meters per second toward the bank this way, which is the slope, so I can write plus 10t. So this is the equation representing Dudley Do-Right's distance from the bank, and the equation representing the robber, the distance of the robber, is 0.2t squared. Now we have to find the point that these two meet each other. So we have to find the point of intersection between these two equations. We are going to use the substitution method, so I'm going to say 0.2t squared is equal to 10t minus 100. I'm going to move these two to the left. I get 0.2t squared minus 10t plus 100 is equal to 0. Or the discriminant in this case is going to be d is equal to b squared negative 10 squared minus 4 times ac, which if you use your calculator it becomes 100 negative 10 squared minus 4 times 0.2 times 100 is going to give us 80, so minus 80, which is 20. Since 20 is greater than 0, we get 2 point of intersection. Now, to find the point of intersection 1 and 2, we are going to use quadratic formula, which is minus b, which is minus 10, which is 10, plus or minus square root of 20 over 2a, which is 2 times 0.2. Now there are two solutions, plus or minus. If we go with the plus one here, we get 36.18. If we go with the negative one here, we are going to get 13.82. So there are 2 points that the Dudley-Do Right is going to meet the bank robber after 13.82 seconds or 36.18. Now, how we can interpret these results is that the first meeting position is after 13.82 seconds. If Dudley-Do Right doesn't catch the robber after 13.82 seconds, since the distance is increasing based on the quadratic equation here, d equal to 0.2t squared. If he misses the robber after 13.82, he is going to see him again after 36.18 seconds, because the robber's distance away from the bank increases quadratically based on this equation, and Dudley-Do-Right, his distance getting closer to the bank, is based on the linear equation which we gave previously.